This unit right here, we're just starting fractions. This is a relatively simple lesson for us. It's the beginning, and we're just talking about some of the basics. The first thing I want to talk to you about is ask over total. Okay, whenever we're dealing with fractions, I like to use the term ask over total. The ask part is going to be the numerator, and the total is going to be the denominator, and I'll kind of show you what I mean about that on this first problem right here. Okay, so on problem number 1, it says, what fraction does the model show? And it shows me one of the fractions right there is 1/5, but I'm just going to double check how many pieces there are between the 0 and the 1. I've got 1 piece right there, 2 pieces, 3 pieces, 4 pieces, 5 pieces. So there's 5 total pieces that the whole is broken down into. So that means my denominator is going to be 5. That's how many total pieces the whole is broken down into. Now, I want to go ahead and look and see how many of those pieces are shaded blue. How many of those pieces are actually shaded blue, Esra?
4.
So there's 4 pieces of them shaded blue. 1, 2, 3, 4 pieces there. So that's fraction right there is 4/5. That's what that number line is representing. Problem number 2. Okay, write the fraction shown as the sum of the unit fractions. And a unit fraction is just one part of the fraction, one part of the fraction. And so the first thing, whenever we're trying to do a fraction, I always like to try to figure out what the total is, how many total pieces there are. And that's how many total pieces there are in the whole. So that's going to be on this number line right here, how many total pieces there are between the 0 and the 1, and total pieces there are between the 1 and the 2. Okay, I could check at either one of those points. I'm going to always like to start at 0. If I have 0 on my number line, I'm going to start at 0. So I have 1 part there, 2 parts, 3 parts. So my denominator is going to be 3. And they already gave me one of my fractions right there, so I can see that my denominator is 3. So that first one that I marked there is 1/3. Okay, the second one is 1 more third. Okay, the third one right there is 1 more third. Okay, I got past 1, I've got another third plus 1/3. Okay, past that one I've got 1 more third. Okay, and adding fractions is really simple. You probably haven't added fractions before, but it's a very simple concept. Okay, whenever we're adding fractions, our denominator always stays the same. So my denominator is going to be 3 on my answer, and all I have to do is add my numerators. And that's 1, 2, 3, 4, 5. 5/3. And that's how we show the sum of the unit fractions. Question number 3. What does the denominator in a fraction tell you? And the denominator tells you how many parts the whole is broken down into. So let's see if I can. How many holes are how many parts the whole is broken down into? Okay, number 4. Okay, and go back to number 3. Okay, that's how you tell what the denominator is, and that's just how we did it on number 1 and number 2. It's how many parts the whole is broken down into. Now, number 4, and that's the total part of my ask over total. Number 4. What does the numerator in a fraction tell you? Okay, the numerator tells you how many parts we're talking about. How many parts we're talking about. So what I wrote is how many parts they are asking about. That's the top part of my fraction. Okay. On the independent practice, I'm going to go through and I'm going to do the even numbers, or we're going to do the even numbers together, and you're going to go back and do the odd numbers on your own. So Problem numbers, well, let's read the instructions first. Okay. In 5 through 8, write the fraction shown by each model. Okay. And we got our ask over total right there. We can look at that. So on number 6, how many total parts are there in 6? How many total parts are there in 6, Jacob? No, that's not how many total parts there are. How many total parts are there, Allison?
2.
There's 2 total parts. That whole, this whole right here, is broken down into 2 parts. So that's going to be my denominator. Okay. How many parts are shaded blue? Julian?
1.
1. So that's 1/2. And that's what Jacob was trying to say right there. He was saying that that's 1/2. And we're kind of breaking it down before. I know you can look at it that half of them are blue. And that's a common fraction that we use all the time. We call those benchmark fractions. But problem number 8. How many parts are there in that rectangle? How many total triangles are there? How many total triangles are there? Bethany.
8.
There's 8. Let me check here. I haven't counted them yet. That's 1, 2, 3, 4, 5, 6, 7, 8. So 8's my denominator. Okay. How many of the triangles are colored? Mary.
5.
5. 1, 2, 3, 4, 5. So that's 5/8. Problem number 10. Okay, on problem number 10, how many parts is that number line broken down into? How many parts is the number line broken down into? Ryan?
6.
6. Let's see. That's 1, 2, 3, 4, 5. 5. Oh, I'm on the wrong one. I'm sorry. 1, 2, 3, 4, 5, 6. That's right. So there's 6 parts. Oh, I haven't read the instructions either. So in 9 through 12, write the Write the fractions shown as the sum of unit fractions. So that's going to be very similar to our problem in our guided practice up top there. So that's right. There's 6 equal parts there in between the whole. So I'm going to break it down into 6, and that's 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. Let's see, I got 1, 2, 3, 4, 5. So that's my 5. That equals 5/6. Okay, problem number 12. Problem number 12. How many parts is the whole broken down into? How many parts is there between the 0 and the 1? How many parts are there between the 0 and the 1? Misty, how many parts are there? Say again? 5. Let's check and see. It's 1, 2, 3, 4, 5. So yes, there's 5 parts there. So my denominator is going to be 5, and I can see it over here when I get to the total over there. So I'm going to break it into fifths, and it says I got 8 of them. So that's 1/5 plus 1/5 plus 1/5, 1/5. Let's see, 1, 2, 3, 4, 5, 6. I got 2 more to go. Plus 1/5 plus 1/5. And that's going to, I'm going to put my equal over here. Means the same thing, 8/5. So the way I wrote it is 8/5 equals 1/5 plus 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 1/5. Tongue tire. So go to the back page. Question 14. Kathy bought a pen for 79 cents and a notebook for $2.49. Sales tax was 25 cents. Kathy paid with a $10 bill. How much change did she receive? So what's one way I can solve that? What's one way I can solve that problem? Jacob, what do you think?
Adding the numbers.
Adding the numbers, so I add $10 plus $10 plus 25 cents plus $2.49 plus 79 cents? No, that's not how I do it. What do I add, Jacob?
You add 79 cents, 25 cents, $2.49.
Okay, let's do that. So I'm going to put my big one up top here. $2.49 plus 79 cents. Okay, plus 25 cents. Is that what I'm supposed to do, Jacob?
Yep.
Okay. So 9 plus 9 is 18. Excuse me. And 18 plus 5 is 23. Am I right? Okay. And see if there's any numbers when we put together there. There's no numbers that's going to equal 10. But I know 7 and 4 is 11. That's 12, 13, 14, 15. Bring my decimal down, carry my 1. And 2 plus 1 is 3. So that's $3.53. That's how much change we're going to get back, right? Is that how many change? How much? No, it's not.
No.
How much? What did I do to figure out how much change I'm going to get back? Abby.
U minus $10. 10 minus 50.
Okay, let's try that. So $10 minus $3.53. So I'm going to subtract that. Cannot take 3 away from 0. I cannot regroup there. I cannot regroup there, so I'm going to go all the way to the tens place to regroup. That'll be a 0, and that becomes a 10. Now I can regroup to my tenths place. That becomes a 9. That becomes a 10. Now I can regroup to my hundredths place. That becomes a 10. Now I can go ahead and start my subtracting. 10 from 3 is 7. 5 from 9 is 4. Bring my decimal down. 3 from 9 is 6. And that's it. I cannot take 0 from 0 is 0. So that means that you're going to get $6.47 back. And as you can see, I didn't do my clubs here either, did I? Okay, I'm boxing in my question. Okay, and what I want to do, the part of boxing that in, is making sure that this answers that. Problem number 16. Jupiter's closest distance to Earth is about 629 million kilometers. Jupiter's average distance from the Sun is about 728,412,010 kilometers. Write both these numbers in standard form and compare them using less than or greater than. Okay, so I'm going to go ahead and underline the important information there, or circle the important information. And I have 629 million. And for the next one, for Jupiter's average distance to the Sun, I've got 728,412,010 kilometers. Big numbers there. So I'm going to write the first one first. I'm going to write Jupiter's distance to the Earth. That's 629 million. So 629, comma. And it's just, so millions. Okay, that's 629 million. I'm running out of space there, so I'm going to put my symbol in between here, I guess. So my next one. I'll leave it on the board there. 728 million. So 728 million. 728 million. 412,000 that's comma 10. kilometers. So, which is greater, 629 million or 728,412,010 kilometers? What do you think, Andrew?
728,412 kilometers.
412 what? I think you left a part. 412,000. Good. You may have said it. I may have just misunderstood. So since that's the second one's greater, if I had a point over here in this area, I would have the less than symbol there. That's 629 million is less than 728,412,010. Okay, and the last problem. Okay, the picture shows 4/5 of a group of soccer balls. How many soccer balls are in the whole group? And explain. So this is going to be a little bit. It's going to be a little bit tricky problem. It's something we haven't really covered fractions this in depth yet. But okay, I can see 1, 2, 3, 4, 5, 6, 7. I see 8 soccer balls there, and they're telling me that's 4/5 of them. That's 4/5 of soccer balls. So I'm going to write 4/5 right here. That's 4/5 of them. Okay. Now I can see that there's 1, 2, 3, 4, 5, 6, 7, 8 soccer balls there. There's 8 soccer balls there. So that's going to be my other numerator. I do not know what the denominator is there. I do not know what the denominator is going to tell me. This part right here. It's going to tell me how many soccer balls are in the whole group there. So I can kind of look in the bag there, and it looks like, you know, there's some more soccer balls in that bag there. So what I want to try to figure out is what the denominator is right here. And fractions are kind of go along with what we was talking about last week when we was trying to create equality in the equation. So if I want to make a 4 into 8, if I want to make the 4 into the 8, what would I do to that? What would I do to 4 to make it 8? Ryan, what would I do to 4 to make it 8?
Add another 4.
Add another 4, okay. Usually when we're dealing with equations, though, we do something other than that. Is there anything else we could do to 4 to make it 8? What can we do, Graydon?
Multiply it by 2.
Multiply by 2, and that's what we're going to do. We're going to multiply that by 2. So we know 4 times 2 equals 8. That's a true statement. So on fractions, one of the rules that we're talking about is kind of similar rule to when we're trying to create equality in our equations. Whatever we do to the top of a fraction, we got to do the same thing to the bottom. So 5 times 2 equals, what's 5 times 2 equal? Allison?
10.
10, very good. So that's telling me there are 10 soccer balls. I should label that. Soccer balls. There's 10 soccer balls in the entire group. Okay, and that may be something that's kind of new to y'all. I know y'all probably haven't seen anything like that before, but that's something that you're going to learn by the end of this unit. Are there any questions? Good.